Vacuum testing a concrete form tube for use as a structural component of an iron lung respirator. So concrete form tubes are used when you want to create a pylon or a pillar. Basically they're cardboard, and here's an example of one that would be used for, say, a deck or something. You drill a hole, put this cardboard tube in there, and then fill up with concrete. Or you can use make it a pillar, as they have in some sort of building. So an iron lung respirator. So the idea is that we're looking at an alternative to having an iron lung like this. What can we do today using commonly available components and build one of these quickly? So in the 1930s until the 1950s, polio paralyzed or severely weakened a person's ability to breathe on their own. The chamber aided breathing by using an alternating pressure vacuum cycle to move air in and out of the lung. It's non-intrusive as the mechanism is outside of the body and airwave. The polio vaccine in the 50s basically stopped polio. There's only a handful of people today in North America that still use an iron lung. This project is intended for use as a last resort in a catastrophically overloaded healthcare system, where the alternative is denial of ventilation due to lack of equipment, resulting in a significant probability of death. This is a project looking for a solution where the majority of the ventilator can be constructed from locally sourced components, such as the hardware store, anywhere in the world. This project is the last-ditch effort to save people. This project is the worst case scenario project, and none of us hope that it gets to that point. Ventilators are not toys and can damage a patient's lungs or kill the patient if not used properly. Only qualified medical personnel should be operating them, or those under the direction of a qualified medical person. I was working with the pandemic ventilator design team, and they were looking at making a negative pressure ventilator, a portable iron lung, or a mobile iron lung. As a side project, I was doing historical research, and I realized that maybe with today's technology that we would be capable of making an iron lung using readily available components. I contacted Sonoco, who make concrete form tubes. Their response was these are not normal times and that they would be willing to help vacuum test. I sent them an email, and basically I asked, is it possible that you could test a sealed 6 foot by 30-inch sonotube with 2.5 psi of vacuum? This would be 4 times the working vacuum of an iron lung. I'm moving forward with building an iron lung using 55-gallon drums, but want to provide a second solution. Now we have a disclaimer here. These tests were conducted in response to the request received on March 31st, 2020. The test results are for informational purposes only. Sonotube forming tubes are not designed for medical uses, and Sonoco specifically disclaims any warranties that they are fit for any medical purpose. As we said, these are not normal times. So, what they did is they tested a 30-inch sonotube rain guard round concrete form. 30-inch diameter was chosen because of a person's shoulder width at the center of the tube. So what we're finding with the coronavirus, or COVID-19, is that obese people or very large people are very susceptible to have respiratory failure. So we want to make sure that we could test something that would be large. If a 30-inch diameter tube would work, then we know that a smaller one, a 24-inch diameter, would work also. These tubes are 12 feet in length, and they cut them into 2 6-foot lengths to produce the inner vacuum chamber tube. Now what they did is they took the second 6-foot length and they used it to create an outer reinforcing support layer. So this is their test setup. They got the 30-inch tube in here, and they sealed it using silicone to some plywood here. Then they put an outer jacket. They split the second one, put it on top, and then they put strapping on it to reinforce it. They had a 1-inch diameter hole in the front plate for the vacuum line, and then they also had a 2-inch ball valve to adjust the vacuum level. They closed the valve to increase vacuum, and then they also had a 1-inch hole for a 1/2-inch diameter vacuum line, which would be used for a manometer. So this is a close-up of it. So basically we have our tube, and you can see the tube down here. Then they put the second one, cut it in half, put it on top, strapped it together for reinforcement. They used a vacuum pump with inlet ball valve over here. This would be the ball valve they used. Not the other one was for releasing pressure. This would, or releasing vacuum. This would be for controlling the vacuum. A manometer, basically very easy to make a manometer. What you do is you take a piece of clear tubing, you add, they use blue ink with water on it, and then you just measure off the number of inches. And test point targets set at 8, 16, 24, 32, and 36 inches on a yardstick to correspond with 16, 32, 48, 64, 72 inches of vacuum. Right? And this would correspond to 1, 2, 3, 4, 4.5 times the working vacuum. So the test number 1 was a reinforced tube. Very first thing they did was do a 16-inch water column, and there was no signs of air leaks or other signs. They went up to 32-inch water column. There's no signs of air leaks or other signs of distress. 48-inch. Basically, the plywood plates appeared to be bowing inward slightly. These are the plates at the end. The pump was shut off, and the end plates were reinforced with additional 2x4s. They went up to 64-inch water column, which is 4 times the working vacuum. One of the things is that with vacuum, there's probably about at least four different standards used for measuring. The ones that we use for iron lungs is centimeters of water. There's also inches of mercury is another one. There's inches of water, there's PSI, and there's atmospheres. The unit that we're interested in is centimeters of water. And they use, which we wanted, our normal operating is 40 centimeters of water. 4 times that would be 160 centimeters of water, which equivalents to 64 inches of water. They went up to 72 inches water column, which is 4.5 times the rated, and there's no signs of air leaks or other signs of distress. So that's very positive news. This shows the results of the readings. So it's documented on the upper leg of the manometer reading. So basically this is the water column, and this is coming up, and we have a yardstick that is measuring it to say what the positions are. So that way they can be documented, and that for the different tests. Test number 2 was a non-reinforced sonotube. So they took off the reinforcement on it, and it was an unsupported sonotube to see if it could achieve 4 times the working vacuum target. The plastic strapping was cut off of the outer support tube. So basically the outer support tube doesn't have the plastic strapping on it, but it still has, it looks like it still has the outer shell. Pump was turned on, same procedure. They went to 16 inches, no signs of air leaks or other signs of distress. 32 inches was good, 40 inches was good, 66 was good. And then what they did is they went to 72 inches, which is 4.5 times the work. There were no signs of air leaks or other signs of distress to the sonotube, and then it failed. Right? The unsupported sonotube failed to collapse inward at one end shortly after the 72-inch water column was reached. And it was before a photo of the manometer could be taken. This is the results of failing at 72 inches, which is 4.5 times the working pressure, and we can see that it collapsed in here and in here, right? And it also buckled, and then it was damaged here. So this was a good test, because what they actually did is they took it to 4 times the working pressure and beyond to see how far it would go. So conclusions: a 30-inch sonotube concrete column form reinforced with a support sleeve withstood a vacuum level of 72 inches, which is 4.5 times what I had asked them, and there was no indication of distress or impending failure. The same 30-inch sonotube concrete form, when the reinforcing sleeve was removed, withstood a vacuum level of 66 inches of water column, which is more than still more than what we wanted. We wanted 160. They went to 167 centimeters. But it did fail when it went up to 182 centimeters. So this is very positive. Sunoco, recommendation here, if concrete column forms, Sunoco and others were used in this iron lung application, highly recommended to use the reinforcing sleeve option as tested here. Again, disclaimer, these tests were conducted in response to the request received on March 31st, 2020. The test results are for informational purposes only. Sonotube forming tubes are not designed for medical uses, and Sunoco specifically disclaims any warranties that they are fit for any medical purpose.